Welcome back to our Python Quickstart tutorial. Today's topic is on file I/O, which deals with reading from files and writing to files. Welcome back to another session on how to manage file input-output from within Python. I showed you so far a very simple text file. The simple text file is nice, easy to read line by line. I mentioned that what we have is we only get typically strings. And I mentioned also that strings benefit from the strip and the split method that allow us to remove white spaces. And the split method is actually one that allows us to take a long string and break it at key characters like commas or semicolons. I'm gonna go back to my simple data text file that was a list of strings that looked like comma-separated lists. How do I read this? We start with our original code where I say, I open the file, I look at it line by line. When I'm done, I'm closing it. Inside the loop, I want to show you a little bit what else happens to this file. What I'm doing is I want to print. What do I see? And all I do is I clean out the white spaces. Then I do a split at the commas. And the last operation I want to explain after we look at the data. So that is the file that I looked at originally. What did we look at? We get a line, and you see here it's marked, we see it, it's quote. This is a string. If I run that string through split, split creates a list of individual strings. And as you see, I forgot to remove the end of the line here. The end of the line, the new line has been removed. I did here the strip method, and I forgot strip in here. So I could do this here by saying I first strip, that removes the white space, and then I split. This removed the new line here. Doesn't matter either way, it's fine. So I want to go back here because for my demonstration, I want to show that this is not necessary. And the important part, split, breaks it into substrings. So these are still strings. You cannot do any mathematics with that. In order to convert it, we need to convert these substrings to floats. And that's simply done with the float command. Float converts a string or whatever into a floating point. Int converts to an integer. str converts to a string. So it's basic conversion techniques that we need here. And I want to use this to show you a trick. How can you convert a list of items to a list of different items where each of those items is a conversion? The string 2 to the float 2, this string to that float, and so forth. If you convert the float outside the list, it doesn't apply because it doesn't know how to convert a list to a floating point number. But if you want to do a list, that's something that we typically would have to grow a list with multiple commands, multiple statements in a for loop. And there's a quick conversion. We normally would do something here that would say for s in string list, and then we convert this to, let's say, x is float s converts 1, and then we need the float list. We would have to start this out here. Float list is an empty list. As I get 1, we say append, grow that float list, and add that X. This is a scenario that we find quite frequently. So we have a list, we go through another list, and for each element we need to do something. In this case, it's float, and then add it to that list. There's a Python short form for this that does this. Think of it this way. You see the brackets on the outside. I want the list. The elements in that list shall be an operation that you do on a member of a different list, and that's where it says do float s for each s in string list, and that converts that with an annoying construct into a very elegant short little list. So I simply get rid of this again, and this implicit form allows me to go every line of the file. That's the line of the file. First step, I split it into substrings, and the second one, I convert the data type to where I need it to be. That's a quick and easy way. Now I have input that I can actually do computations with. So that's as far as I want to go with my own simple text files, reading and writing them. Unfortunately, we typically don't get simple text files. Nowadays, different people send it in different list formats, but it's typically one sort of spreadsheet. Excel, numbers in the Mac, LibreOffice has things. So a lot of different ways. Google has them too. So we could go into our spreadsheet program, export as text file, export as comma-separated list, and then write our own code to read it. That works if we know exactly how the data is organized. The thing gets much more annoying if we get different data from different people, and we need to try and figure out what's going on there. Luckily, there is something very powerful around that too, and that's called the pandas library. I provide here a link. I highly recommend you spend some time and look through that library. This library gives an easy interface to Excel, but also to database formats and many more. It's just an easy, user-friendly interface. It's providing its own data type to make our life easier. I want to just show you a few tips and tricks what can be done. So this is a crash course. I actually copied some stuff from the Panda libraries to show you what it can do. I also have here a little warning. If you work on your own machine, you may have to install some additional material. It's also on our website. It's not in the default Python installation. So once you have Python installs pip or pip3 depending on your installation. And you may have to add this command in the command line. It goes quick, but it's important to have it. Let me show you what this can do. First, I need to load the pandas library, and as with NumPy, I don't like to type a lot, so PD pandas is a quick and easy way. You want to read a file? How about PD read Excel? And actually it has text file stuff too. PD read Excel is actually nice. It reads it and it also shows it. So you can right away see it. Careful, it doesn't read the entire Excel. It reads one sheet in that. When you downloaded the stuff from GitHub, I provided an Excel demo. Careful, don't write to it. You may overwrite it. But if you have my original saying, it should look like this. It's about 300 rows plus a header that makes 301 rows, and it's columns, and it's emulating an earthquake record. It's just some fake earthquake record. There are other ways of dealing with this, and that is if you want to process the data. Right now, that read Excel read it, showed it to you. It's a quick glimpse into it, and it's gone. If you want to process it, you need to assign that file to a variable. The variable, hey, that's the Excel extension. That means there's pretty much no creativity in that file name that I used, but whatever. It's a file name. I say, give me access to that Excel file. And then I can read this directly from it. It makes it a bit more direct, that I don't have, if I need several spreadsheets, I don't need to have that file name in multiple locations. That's beneficial if you have to change something later. You only want to change it one place at a time. And now I want to load the sheet for wind. So let's try that. I load that sheet, and I have this in my variable df. If I print df, that's another way of dealing with it. I get here a similar form like that spreadsheet, just in a more computerized column. The sheet wind basically has X and Y for 3 different points over time, and I put 1,000 lines into it. So df, if you look at this, looks like an array, but it is its own data type. The nice thing is, if you look at this, pandas is smart enough to recognize that there are in the Excel files, the first row are your names for the variables, and you can access them, the rows, based on the names in your Excel file. And this looks now pretty much as if you're using a dictionary. It's not a dictionary, so don't be surprised if it doesn't work that way, but it's actually really nice. You can pick this and pick the individual columns and say, give me the time column or whatever. The other thing where this is really helpful is if you want to plot stuff straight from an Excel file, we learned how to use matplotlib. So let's import matplotlib again. And I haven't used it. There's the subplot command that means create a plot that has one row, 2 columns, the first plot, where this is the same plot, 1 row, 2 columns, the second plot. In the first plot, I plot time on the x-axis and the x component of node 1 in red, and time on the x-axis versus on the y-axis, the y component of node 1 in blue at the grid. On the second plot, I plot x versus y for node 3 in green. Let's do this. And I just created the plots straight out of an Excel file. And nothing against Excel. I like Excel, but I like that I can use now my plots, make them in high quality, fully automatic, add extra information, export them as PDF if I want, and use them in my publication. So really, really powerful, easy to use, easy to interact with, and pandas also allows us to write files, to use different types, etc. So for you, I'm not reading the manual for you. I want you to know that this library is the way to go if you have external data that you need to bring into your Python code. So really, really important to use it, and important to read this. I want to look in this just one little bit, and I copied a quick read from the manual. You can go straight to the manual. You see that I copied that example. It's a data frame. That's the actual data type. It looks like a matrix. It's a spreadsheet data type that has a little bit extra functionality. You should have seen that already in Python. We use similar data types, but it's the functionality that makes things that look alike behave different, that makes it powerful. Again, all this, here's the source. It's taken off the manual. but you can create those spreadsheet types, data types, where you have rows and columns in there in a very simple form. You have that data frame, pandas data frame object, and the objects, as you realized above when I looked at the time column, it behaves a bit like a dictionary, and that's used when you create that data frame. The data frame object wants the data as a dictionary. So there's a dictionary with the keyword name and a list. There's a dictionary with the keyword word age and a list. A dictionary with the keyword sex and a list. What does it mean? The keywords, these are your column labels. The lists are the columns under that label. So if we create this and we look at this, it created a spreadsheet that has name, age, and sex, and you have the first list, the second list, and the third list as columns. And last but not least, we can also use those and write directly into an Excel file. And this command is pretty easy. Again, you have a data frame. That's one sheet. That data frame, that's this variable. You can write to Excel. That's the Excel file. And you can make a sheet. I want to warn you, I only played a little bit with it. I typically succeed with one sheet. You need to be very careful because this thing overwrites your Excel file. If you think you're adding a sheet, you may instead throw away everything else you have in there. So when you start working with those things, and I do it here and I show you, I have that written here, it's just a screenshot. Be very careful while you're developing. Make backup copies of every valuable files because it's very easy to destroy them by making a little programming error and overwriting the wrong file. And in particular, if you have complicated Excel files, you're gonna be crying. So careful. The right operation is always dangerous because you are risking damaging your original data. Always use copies, always have a safety backup of your original data before you start working with that. And then once you figured it out, it can save you a lot of time, can save you a lot of work, and you can easily combine, read and write data, process data in Python, bring it back to Excel, collect data somewhere else in Excel because your body is not smart enough to learn Python. You pull it into Python and do the magic there, whatever works for you. Okay, that's it for now.